Okay, we are going to analyze circuits with two or more sources, but we are going to look at two sources because it will give you an idea of how to deal with them. Even if there are more, you just do the same thing over and over. Right. So the traditional way of doing this will be what we call the superposition method. We'll start with that, then I will do how you galvanize them, how you could do other methods, so we'll catch off with two sources and whatever. Okay, but let's start with the superposition method now. Superposition method simply says, let's say we have a source, let's say it's 10 volts, we have a resistance, let's say 2 ohms, let's say we have another resistance here, let's say what, 4 ohms, another one, let's make it 3 ohms. We have let's make it long so that people can, we'll do a long example. So much work will be done that by the time we're done, hopefully all the misunderstandings will be cleared. Let's say we have another for 2 ohm, and finally let me bring in a 5 ohm. I think that's enough. Let's put another source. I'm trying my level best to make them straight, but hey, it's not easy. So no, now on this one, first of all I want to reduce the size, then I want to move it to the side. Okay, too much space. Now superposition, what the method basically says is that if I have, let's say I have a 6 volt source here, let me not make it that easy. Let me change the direction of this source here and rather have a source facing in a different way, because that's very important. Okay, so we have V1 here, we'll call this V1 and we'll call this V2. What you need to understand here is that for every leg, for that leg here, there's a component of current that will be contributed by this guy, there's a component of current that will be provided by the other guy. For the 3 ohm, some of the current will come from this guy, from the 10 volt, the other will come from what? From the other guy. If the currents are in sync, if they're going in the same direction, then those currents are going to what? Are going to enhance each other, they're going to add up. If the currents are out of sync, if they're going in opposite directions, then obviously the what? The currents are going to have to what? The bigger current will subtract the smaller current, and then the resultant will be the direction of the bigger current, obviously. Now, what we then do is easier with superposition to say, if we have, let's treat this case, let's only use V1. Let me rather do this. Let me do this. Sometimes just writing things. Let me say using V1. If I use V1, it means my circuit will only have V1. I'll treat my circuit as if there was only V1. I'll not put the values. When I want the values, I'll refer back to the, I'm trying to have my videos as short as possible. The longer the video, the less the concentration. From my experience, people tend to get tired. So if I'm using V1 only, from the perspective of V1, let's suppose that we're asked to calculate for current through the 2 ohm. Let's suppose we are calculating for the 2 ohm. We want to know the current that is going through the 2 ohm. So from V1, we would assign according to what? According to to conventional methods, we are going to assign currents from positive to negative. We are going to say obviously they will split here, they will split there. So again, this current will come here and split there. Okay, so we'll say according to V1, our current across this guy is going to be going downwards. Okay, so now let me just name this. I don't have to, but I want to name it. I just want to name the vertices that correspond to the one that we're doing. That will help me in terms of direction in future. Okay, so now using V1, if we use V1, should I probably have taken it up there? All right, let's just deal with it. Let's do it here. Let me take this guy up there. Let me rather take this guy up there. Using V1, oh, it's that one. Okay, all right. If we use V1, what do you see? The current is headed from A to B. According to V1. Okay, now using V2, probably I should just copy this and say clone it. Let me get and drag the copy and put it here. And I'll say this one will be using V2. I didn't want V1 to be below. This will be V2. Now if we're using V2, we will not have V2. Instead we'll have V1. So sorry, we'll not have V1. If we're using V2, we will not have V1. Instead we'll use V2. I'm saying we will not have it, and I'm putting it. Been doing these videos for a long time now, I'm tired. Okay, we won't have V1, we'll have V2. And remember, this was 10 volts, and this is 6 volts. Okay, but our direction now, let me see if I put it down there. Why? Okay, but I want to see that P. Our direction now is cannot be the same. The directions cannot be the same. They can be depending on how the battery was oriented, but I doubt they would be the same at all, because if the currents will have to first from this side. V2, I said, I'm being careless. V2 we said is facing in the other direction. The negative is on top. Okay, so now our current is therefore leaving that way. Our conventional current is leaving that way. And here, instead of AB like we had from V1, when you're using V1, here we've got the direction of, when it splits there, it's actually B to A. Now, coming here, there's going to be a split again there. But my interest, okay, so now, if here there's a split, that was the direction of the current there. Okay, so if these two, they are going to come and obviously join up there, all right? So that here, ultimately, the total, these two are going to be the supply, all right? So, because I'm using the premise that this here is going to come here together, so obviously this one has to leave back to catch off, all right? So now, but our interest is not there. Our interest is actually only here, all right? We don't even have to waste time with that. If we are given this stuff, as long as we can get the direction here, we are happy. We get the direction there, we are happy. Obviously, here to get the direction, we might have needed to come all the way up to there because it was further. But here, once I got here, I was done, because all I want to know is the direction of the current from what? From a perspective of conventional current. Now, let's calculate using V1. Calculating using V1, what we'll do is, we'll say, If you want the current there, we need to know, oh, we left the value of resistance there. That's a 5. That's a 5. Oh, but I said I won't worry about that. Okay, let me put them so that people are not confused. I'll just put the numbers without the ohms. 2, 4, 3, 5, and 2. And we want the current through the what? Through the 2 ohm. So this here is 3. This here is 4. This here is 2. 2, 4, 3, 2, 5. Now, if we look at this here, this is obviously R parallel. So we're going to say R parallel 1 is equal to 2 and 5. 2 times 5 over 2 plus 5. This here is what? 10 over 7. I don't want to have commas. I'll leave it like that for the time being. Okay. Then I'll go and say, but this is going to be in series with the 3 ohm. So this is going to be 3 plus 10 over 7. This is basically going to be 2131 over 7, because 21 over 3, 21 and 10 is going to give us what? 31. Now, but that is in parallel with what? With the 4 ohms. So this is our R parallel 2. R parallel 2 is going to be given by 4 in parallel with R series 1. So this is 4 times 31 over 7 over 4 plus 31 over 7. Now, if you look at this, this is really going to be a long sum. It's going to be that times 7 is 28. 28 and 31 is going to be 59 over 7. Because if you look now here, this is going to be what? 7 there is going to be 8. 8 with the remainder of what? Of 3 over 7. If I look at this, this is 4 and 3 over 7 is 8 and 3 over 7. So that's fine. This is divided by oh God, I'm doing that. I'm doing addition. I'm treating it like it was an improper fraction. I've done this before. I tend to sleep. I know this belongs here. This belongs here. This is 4 and 31 over 7. This belongs here. What I'm doing there is actually for here. On top there, I'm supposed to multiply, not do it as if it's an improper fraction. This is actually what? A product. I took it as if it's 4 and 31 over 7. Which is strange. Okay. But anyway, 4 times 31, that is 124. 124 over 7. That's what I was supposed to have. This is the same as 4 over 1. 4 times 31 is going to be 12 and 4, 124 over 7. Okay, so which ultimately gives us, if we change this over, it's going to be 124 over 7 times 7. The bottom one is what? The flipped over 59. So my answer here is 124 over 59, because the 2 7s are going to cancel out. Okay, so that's R parallel 2. Our R total from the perspective of V1 is going to be equal to 2 plus R parallel 2, which is equal to 2 plus that's, let's say 59. Okay, let's just do it. 2 plus 124 over 59. 59 is 158. No, sorry. It's 118. 59 is 118 over 59. So 118 and 124 is 118. In 118, that's 140. no, why am I saying 1? Is 2 is 118 244 over 59, because 118, that's gonna be 12, not 42 over 59. 118 12 13, that's a 4 2. Okay, 2 4 now. All right, now 242 over 59, and then that is our R total, which leads us to what? To, do I want to, if I want the voltage there, because that will give me the current there, I can do voltage divider and say V1, I'm working backwards, V across the 4 ohm, V across the 4 ohm here is going to be that, or R parallel 2 over, is the parallel resistance, R parallel 2 over R total, times V supply, which is equal to R parallel 2 is 124 over 59 divided by R total, so I'm going to multiply and convert and invert 59 over 242, okay, that there times the supply of 10. Okay, so that will lead me to what? That will lead me to, let me move up, that will lead me to, I want to see the circuit. Okay, that will lead me to all right, this here 59 and 59 will go, so 124 is 1240, that times 10 over 242. That's my V4. Do I really want, I'm looking for that current, I'm not really, I'm going to leave it as a fraction. I'm not really, there's no pressure for me to change it yet. Now, when I want the voltage there, remember our battery is that side. When I want the voltage there, let me just show people, when I want the voltage here, I've got the voltage there now, the parallel voltage. When I want the voltage here now, I have to say this one here, which is R parallel 1, over R, what was R series 1. R parallel 1 over R series 1, okay? They are sharing that voltage that came in there. They are sharing what? V across the 4 ohm. So I want the V across the what? Across the 2 ohm. That's the one that we're calculating. So I want V across the 2 ohm. We're going to say R parallel 1 over R series 1 times V across the 4 ohm. Alright, I hope you understand what I just did now. I think you should at this stage. Okay, so we want the V across the 2 ohm, which is equal to R parallel 1 over R series 1 times V across the 4 ohm, right? The voltage at that stage there. This part over that part, because they are sharing the total, that part, they are sharing the voltage there, which is V4. So this is going to be equal to R parallel 1 is 10 over 7. It's divided by 31 over 7. So I'm going to multiply and invert. I'm dividing by a fraction, so it's going to be 7 over 31. this is this ratio times V4. V4 is what? 1240 over 242. Okay, so this will give us, if we do that, then the 7s will cancel out, and then we've got cancel out. Was that way? I have not cancelled out. We've got, it's not time. We've got 10 times that is 1,200 and no, it's 12,400 actually, over 31 times 242. 31 times 242 is I will only do the final calculation because this is where I will need my answer. Okay, that will be 31 times 242. My head's going to take forever. 7,502. 7,502. Okay, now with that answer then, 1,2,400, 31 times that times 242. All right, and that there is going to be our V2. I will leave it like that for now. What I want is this is the voltage at point A now. Now, therefore, to get the current, we've got the voltage across the 2 ohm. This is the voltage of the parallel network. To get the current there, we're going to say the voltage to get I through the 2 ohm. We're going to say the voltage through over the 2 ohm, which we have now, that divide by the resistance there, which is the 2 itself. And that is going to be, the resistance is 2, so that is going to be what? That is going to be 12,400 over 7,502 divided by 2 is the same as times 1/2. Okay, now I can put my answer because I need this answer. Now, this is going to be that times 12400, which is equal to times half, which is equal to 0,826. So this is my current there, 0,826 amps. But remember now, the direction is, I would have to indicate direction. I would have to indicate direction. Very critical to indicate direction there. In the direction, that one there was A to B. I'll put it as if it's as a vector A to B. Alright? So, why? Because we're not here. This is the second case. The first case is actually the other direction. Okay, direction A to B. Alright? That is using the one method. Now, we come and say, this is our answer. Now, I'm going to come and say, let me use V2. Alright, using V2, we want that value there. So we have to start here. So our parallel one, in this case, is 2 and 4, which is equal to 4 over 3. Okay, that's 4 over 3 is 8 divided by 6. That's 4 over 3, 1,33. All right, then our R series 1 in this case is this part plus 3, so that will be equal to 3 plus 4 over 3, which is going to give us, this is going to be 13 over 3. Am I right? Yes, 13 over 3. Why am I? Because this is 12 over 3 No. What am I saying? Why am I saying 12? This is 3, so it's 9 over 3. 9 plus that is 13 over 3. So that is fine. Now, when you want our resistance at this part here, we've got the total here, that was R power 1. We've got the series after this is in series with this, that's R series 1. Now we've got R parallel 2. R parallel 2 is simply going to be R series 1 in parallel with the 2 ohm, which is equal to, I don't need to see some of the values here. I can take this up. Okay. Now, this here is the same as what? We've got R series 1 is what? 13 over 3. This is 13 over 3. This is times 2 over 13 over 3 plus 2. Okay? Let's not make the same mistake. This is what? This is the same as, let me move you up because I can see I'm gonna struggle for space. Let me move you up. Okay, so now this is going to be, that is 2 times 13, that's 26 over 3 divide by this here, because this is 2 over 1, 2 times that is 26 over 3. This one here is 6 over 3. 6 plus that is 19 over 3, which is basically a fraction divided by a fraction. So we're going to invert the bottom fraction and multiply. This is 26 over 3 times 3 over 19, which gives us 26 over 19. So, are we correct to say 19? Yes, it's 2 is 6 over 3. 6 and 13 is 19. So it's 19 over 3. So that there is 26 over 3, and then that is 3 over 19. So it's 26 over 19. That is correct. So we've got our R parallel 2. When we've got our R parallel 2, we then need our final thing. There is our R total. Our R total is equal to the R parallel 2 plus 5 is in series with the 5 ohm. That parallel network is in series with the 5 ohm, which is equal to R parallel 2 is 26 over 19 plus 5. Now 5 times 19 is going to give us something like 95. So 95 and 26 is going to be 121 over 19. Okay, so let's see. Are we correct to say that 19 times 5, 9 times 5 is 45. 1 times that is 95. 95, if you take 5, it's going to be 100. If you take 5, it gives us 21. So that's correct. So now we've got our R total. If we got R total now, we can work out our voltage there. For me, the voltage approach is easier. We can do the total current and then do the current divider. But for me, I can work out the voltage there. So I'll go and do that. Voltage across the 2 ohm is simply equal to R parallel 2, that part, okay, over R total. If I do that, I'm gonna get what am I doing? I'm talking nonsense here. If I want the voltage, yes, it's fine. Because I thought the 5 is going to give me the voltage across the 5. So R parallel 2 over R total times the supply V2. I hope this I did say no, not V2. or it's wrong to have called that v2. Why? Because I also use v2 here and I meant something else. So maybe I should call this va and vb, because I already use numbers. I cannot copy and correct all those numbers there. So what I'll do is, rather I say va for this one, okay, va, so using va, and vb for this one, so I can say using vb. So now my v2 here is a v across the 2 ohm, and it's not clashing with that. Now also here I must correct on the main circuit, on the main diagram there, I must correct it. This is, because now I've got two v2s here, which is mathematically wrong. This is vb, this is va. So we'll say using here vp. Okay, so that we don't have clashes with v2, v1, whatever. Okay, using vp. And my v2 is actually the voltage across that thing. The v4 was the voltage across the 4 ohm. So now, just to be consistent, now I'm happy that I fixed that. Now I go ahead and say, we're here. Now we say, okay, now that we've done that, we have our R parallel 2 is 26 over 19. Is divided by R total, so it's a fraction, so I'll invert and multiply. That is the division there, you invert the fraction and multiply, so it's the same thing. Then we are saying here times v2, and our v2 it's not v2, that's how I tried to correct this, it's vp times 6. Okay, so this will give us, this cancels, that cancels, and we've got 6 times 26, that is 156, am I correct, over 121. Now why is this important? This is 36, 12, 15, yes, so this is v2. Why is this important? Why am I leaving instructions? Because I had to commas. This is safer for those people who forget to save their numbers and not to use rounded off figures. You cannot round off a fraction. Okay, so now when I then go on and say, but I need I through the 2 ohm, I2. Okay, so I'll say I2 here, I'll call it I2A, is from source A. This I2B is from the source B. Okay, I2B is simply equal to the voltage across the 2 ohm. Okay, the voltage across the 2 ohm over the 2 ohms itself, which is equal to 156 over 121. This is times half, because that's how you divide by 2. So this is going to be a simple, that is 78 over 121, and this is, I might as well put this, but this is my final answer. Recall A. Right, I didn't store my answer. You see now, this is why I don't like this. 12,400 divided by 7502 divided by 2 gave us 0.826. I didn't store my answer. Okay, that's why the fractions are handy, because now I don't have to redo the calculations. Now I just go to the last calculation that I did. It's actually time saving. The other one now is, there is 78, so 78 divided by 121, and that answer is 0.645. 0.645. 5, but no, that's what I put it here, 0,645, and this here is in the amps, but it's in direction B to A. Using our vector representation there from B to A, as you can see, using VB is from B to A. So now, because the first direction was AB, that direction is BA, our current through that, therefore, current through the 2 amp, I2 is equal to, which is bigger, 2A, I2A minus I2B. Obviously, the direction is of the bigger current, A to B. Now, this means, didn't store my answer in B, sorry. So now, this means 0,826, which is stored in A, minus 0,645, which is stored in B. Okay, so I can simply say recall A minus recall B, and my answer is 0,182. 0,182 amps in the direction of A to B. Okay, it's important to state the direction as well when you're doing superposition. So what do you see? The current that we finally had in that leg, the first component was contributed by the first source. The other component, the first component was contributed by the first source. The other component was contributed by the what? By the other source. But because they're in different directions, we then superimpose, hence superposition, hence the name superposition. We superimpose the two currents and we get our ultimate current. Okay, our ultimate current and our ultimate current direction is wrong. Alright, so you have to specify both the current size and the current direction. So there is our final answer. It is simply, need a pen. Okay, that is our final answer. So I hope you understood superposition. I did somewhat longer. You see, the thing is, this calculation is about practice makes perfect. You have to understand your basics. You have to understand how you get your currents, how you get your what, your voltages at different points. You have to understand your basics. If you don't know your series parallel networks and how they work, you are obviously I don't know whether cloud 9 is a good space to be when you are all over the place not knowing what to do. I don't think that will be cloud 9. You have to come up with a dark cloud maybe or something else. But anyway, I hope you enjoyed that. Let's meet again for our next course.